let's consider the following problem. You can choose one of these two bets to play. So in bet A, you win $12 with probability half, and you lose $8 with probability half. And in bet B, you win $135 with probability 1 over 20, and then you lose $5 with probability 19 over 20, right? So if you compute the expected values here, so the expected value, let's say of A will be 12 times half plus minus 8 times half, which will come out to 2. So if you play bet A, you would be, for every dollar you well, not for every dollar you bet, you need to be betting in the way that it's decided here. So, but the point is, as you play bet A, you would be expected to win on average $2 per play, so that's good. So it's a beneficial game. And if you compute the expected value of B, you'll win $135 with chance 1 over 20, but you'll lose $5 with chances 19 over 20. And if you compute this, you get the same $2. So from the point of view of expectations, both games are the same. You're expected, for each time you play them, you're expected to make the same amount of money. But which one is better, or is there a way to look at that, or how to think about that, right? It seems like the one on top is a little bit more stable than the one on the bottom. So the one in the bottom, most of the times, you're losing money, and then every now and then you make a lot of money. And the one in the top, half the times you're making a little bit more money, and half the times you're losing a little. So it seems like a risk, more of a risk thing, right? The bottom one somehow seems like a riskier bet than the top one, even though in the long term, you can make about the same amount of money on average. So how can we measure risk? So one of the ways of measuring risk is through something called variance. So variance is like a measure of spread, and the way it's defined, so if you have a random variable x, and mu, let's say, is the expected value of x, then the variance is what's the expectation of the difference squared. So the difference squared, it's sort of like calculating a distance. So how far do you expect x to be from the average, right? Now you can open this up, use linearity of expectations and so on, and you will be able to calculate that the variance will be the expectation of x squared minus the expectation of x all to the squared. And sometimes we also look at the square root of the variance, and that's called the standard deviation, right? And the main idea is simple. It's the idea that the expected value measures the average, and the variance measures how spread out the outcomes are around that average. So let's take a look at that. So if we look at our bet A, so again our bet A was you win 12 with probability half, you lose 8 with probability half. And so we're denoting it by this random variable XA here. So then the expected value of XA, which we already computed, but we can do it again, is going to be the 12 times half plus the minus 8 times half, which is equal to 2. And now the variance, so what is the variance of XA going to be? So it's going to be the expectation of XA squared minus the expectation of XA, and take that to the power of 2. Okay, so what is the expectation of XA squared? the other one we already computed, right? So this is gonna be, so it's gonna be the 12 squared times half minus, so plus, minus the 8 squared times half. And so if we compute this, this will be 144 plus 64 divided by 2, which is equal to 104. And so what this means is that the variance of XA is going to be that number, the 104, minus the expectation of XA, which is 2, squared. And so this will just be 104 minus 4, so this will be 100. And so this is our variance for this variable here. Let's compute now the variance for bet B. So like we did before, let's compute the expectation of this bet. So this is going to be the 135 1 over 20 plus the minus 5 with probability 19 over 20. And if you compute this, you get just 2. And so now, how do we compute the variance? Well, as before, it's going to be the expectation of xb squared, minus the expectation of xb, which we just computed, that squared. Okay, so what is the expectation of xb squared? So this is going to be the 135 squared times 1 over 20 plus the minus 5 squared times 19 over 20. And if you compute this, it'll give you 18,225 divided by 20 plus 475 divided by 20, which will be 18700 divided by 20, which will be 935. And so this means that the variance of this bet is going to be 935 minus the 2 squared equal to 931. Okay, so if we compare both of them, so we saw that the expected value are the same, but the variance of A was $100, was 100. The variance of B was 931. Now, if you take the square root of that, you get the same units as this. So the square root of this is the standard deviation. And so the idea is that bet A and bet B have the same expected value, but bet B has a much higher variance, right? And so what that means is that bet A is the safer bet, so the possible outcomes are closer to the average, and bet B is the riskier bet. It usually loses a small amount, but sometimes wins a large amount. And neither choice is automatically correct, right? If you care about steady gains and avoiding large swings, better A may be better. But if you're willing to accept more volatility for the chance of having a larger payoff, you might prefer bet B, right? So best choice really depends on what is the objective. If your objective was to make a lot of money in very short amount of time, you might want the variance, right? And if it's a long-term thing, you maybe don't want a high variance.